before we start. First one is a reminder about the quiz. Quiz number 2 will be inshallah next Tuesday. It's very similar to the same setting of last time. It will be about chapter 2. I already posted in the general channel a file that contains your attendance and the participation data as of my record up till end of last week, week 5. So please check it out and let me know if there's anything that you think it's wrong in the file. As we agreed, every absent is minus 0.5, every late is minus 0.25, half an absent. So, and those who have accumulated already several absences, please make sure that you attend more often, more regularly in the remaining of the semester to avoid any DN. And to avoid also deduction of marks. Okay, so last time we started talking about chapter 3 and we started the expectation. Today, inshallah, we'll continue with the expectation and we'll talk about also the moments, inshallah. So the expectation, we mentioned that expectation or the expected value of x or the mean of x or the statistical average of x all mean the same thing, which is the average of a random variable x. And we talked about example in the discrete random variables, for discrete random variables, for continuous random variables. And then we talked about if I have a function of a random variable and I'm not interested in finding its PDF, then I can also find the expectation of that random variable or the expected value of random variable by replacing y inside the expectation and then basically replacing the function inside the expectation. And then calculate by basically putting inside whatever inside the expectation operator next to instead of x in the calculation. And then we came up to this general rule for continuous random variable. The expected value of a function of a random variable g of x equals g of x multiplied by the PDF, and we integrate. And for discrete, it's equal to the summation where we replace xi by the function g of xi multiplied by the probability of xi. And we stopped here basically in the example. So before we continue, Shabab, any question about last lecture? Okay, so we have here a random variable that is Rayleigh distributed with a equals 0. The Rayleigh distribution was this. The PDF was basically this. There is an A where the distribution starts. So it looks like this at A, something like this. Okay. Now A here is 0, so it starts at 0. So we have here the random variable starts at 0. Okay, so this is basically the random variable f x of x, or the PDF of the random variable. Okay, and b equals 5. So in this function here, b equals 5. So basically here we have the voltage. We call it here v. So let's remove the x and we call it v. F of v. So basically b equals 5. It gives you this PDF. 2 over 5 v e2 minus v squared 5 over 5. And it's 0 before 0. Now we are interested in the expected value, the average value of the power over the 1 ohm resistor. Okay, so basically here we have a voltage that goes through 1 ohm resistor, and we are interested in the power. What is the value of the power in terms of the voltage, Shima?
V squared over R.
V squared over R. So the power here is V squared over R. V squared over R. And we have R equal 1, so it's V squared. Right? So basically, we are interested in expected value of V squared of P, which is equal to expected value of V squared. Now I can do this using 2 approaches. One approach we know, the other approach we did not learn yet. The first approach is to find the PDF of P, which we did not do yet, not yet. And then find the average of P. So basically do this and then find expected value of P. But we don't have the PDF of B. And also sometimes it's not worth to calculate the average, the PDF of B, because it might be very complicated to do that. What I'm interested in is the average power, which is this. And this we can do using expected value, using basically minus infinity to infinity of V squared F of V dV, as we learned before. And when we do that, we end up with basically an integral from 0 to infinity of the PDF multiplied by V squared. So here we have V to the power 3, because we have a V here multiplied by V squared here. We end up with V to the power 3 E2 minus V squared over 5. And we can do this by integration by part, and we get equal to 5 by doing some change of variable and then integration by part. Okay? So now we were able to find the average power without going through the finding the PDF of P. And as I mentioned, in many cases, it takes a lot of time to find the PDF of P, as we will see later. And it's not worth it. We are not interested in more than the average of P. واضح شباب؟ Any question? Okay. Now, what about if I'm interested in conditional expectation? Conditional expectation, if I have a specific condition B, then basically for continuous random variable, expected value of X, random variable X, given the event B, the condition B, it's nothing but the integral of X. However, the PDF now is different. It's the PDF, the conditional PDF of X given B. And we know how to calculate this before, chapter 2. And for discrete, the expected value of X given B is nothing but the summation of Xi multiplied by the probability of Xi given B, which we know how to calculate for a specific condition. I'm just reminding this of what we have done before. So, for example, if you have B is a range, X, which is B, is an event range, which is basically, it's equal to the set of X less than or equal to a specific number B. Then the conditional PDF of X given X less than or equal to B, if you recall, it's equal to the PDF divided by this number. This is a number, this is a number, which is equal to the probability that X is less than, is basically less than or equal to B. This is for the range of X less than B. For X greater than B, this is equal to 0. It cannot happen. And hence, if I'm interested in the expected value of X given X less than or equal to B, it will be whatever the function is here only in the numerator. Whatever in the denominator is a number. So this is only a number. So, and because of that, the expectation only works on the above, in the numerator, because the function of X is only in the numerator. So it's the PDF of X. So basically this is expected value. It's basically the integral from minus infinity to B, not to infinity, of X, fx of X. Not infinity, yeah? As in expected value of X. We don't integrate to infinity, we integrate only to B here. Okay. Any question, Ishmael? So simply, the conditional expectation works very similar to the expectation, except that we only use the PDF, the conditional PDF, which is if X given B. We don't use the normal or the original PDF. Let's have a practice and try to find this. We have a random variable X with a PDF that is given by this. It's a specific function. Doesn't mean anything. It's not a well-known PDF. And it's only defined from 2 to 6, and it's 0 elsewhere. The question is find the mean. Okay, Shabab? Let's find the mean. What is the mean here?
4.
How did you find it's 4?
The middle point. It's from 2
Again?
to the middle point. It's from 2 to 6. So
Okay.
6 the subtract by 2, I get 4. The middle point.
And when did we say that the average is the middle point? Where did you learn that? Yeah. And الآن أنت you assumed here this is 2, this is 4, this is fx, this is fx of x. What you assume that this is equally likely from 2 to 4. Does this function looks like this to you?
No.
How did you say it's 4? So it's up to 6, I mean. Shabab, try to use what we learned, please.
I calculated and it will be equal to 1.
Equal to 1, huh? How did you find that? طيب شباب, what is the expected value of, what is the mean here? تفضل.
The integral from minus infinity to infinity.
Yes. Yes. Of x
of x.
طيب. And then we integrate from where to where?
From 2 to 6.
2 to 6, because this is the PDF range here. And we put the PDF, which is 3 over 32 minus x squared, yes, plus 8x minus 12 dx. Now up to here, this is EE315. Sorry. Up to here, this is EE315. The rest is calculus. Here, 315, here, calculus, math. 101.
Doctor, should we multiply by x?
Sorry, I forgot to multiply by x. Thank you. So it's x, thank you. So we multiply x fx, and we x fx. Thank you very much. So this is the PDF, and this is x. So the rest is just calculus. We have 3 integrals here to calculate, right? What is this? It's 0, this is 2 to 6, and we have here a constant of minus x cubed dx. And we have here plus another integral from 2 to 6 of 8x squared dx. And we have the last one from 2 to 6 minus 12x dx. And all multiplied by the same constant, 2 over 3. طيب يا شباب? Now if you calculate this, what do we have here? 2 over 3. And this is the first one is minus x to the 4 over 4 from 2 to 6 plus 8 over 3 x cubed 2 to 4. And we have here, minus 12 over 2 x squared 2 to 6. And if you calculate this, how much do you get? 1?
4.
4?
Because
Are you sure 4?
First time I calculated, I forget x multiplying by x.
Are you sure, Shabab, it's 4?
I think it's 64, Doctor.
Yeah. I don't think it's 4. يعني شوفوا انتوا الارقام الكبيره هنا مستحيل تكون 4. 64. anyway check this up, calculate this شباب. مستحيل تكون 64 also.
Doctor, I got two. I use calculator. I
طيب.
get 2 over 3.
2 over 3. طيب يا شباب، واحد جاله 2 over 3 والثاني جاله 4 والثالث جاله 64. which one of them can be an answer?
Yes, it is
طيب
4.
بس قبل ما نكمل يا شباب، which one can be an answer? can be a correct answer. بس عشان نحلل أجوبتكم. can 64 be a correct answer?
No, it's out of the
No,
range.
out of the range from 2 to
out of the range. مستحيل يا شباب يكون، يعني أول شيء البي دي اف شكلها مو كذا بس امسحها. البي دي اف is anything else whatever. مستحيل 64 لأنه لازم المين يكون between 2 to 4 2 to 6 sorry. نفس الشيء. so this cannot be true. 2 over 3 ايش رايكم؟ مستحيل صح؟ لأنه برا الرينج بعد 2 over 3 هنا. مستحيل يكون الافريج of a random variable that is defined between 2 to 6 is 2 over 3. So 4 could be a correct answer. Check this up يا شباب and give me a final answer. لا تنسوا هذه الماينس ها؟ minus 6 x to the power 4 divided by 4. 2 over 32. أنا جالس أنسى أشياء وألخبطكم معي. 2 over 32. Sorry, 3 over 32. From where did I get 2? It's 3 over 32. معليش أنا ملخبطكم ترى معي. أكتب أشياء خطأ وأنتم ماشيين معي. طيب. Anyway, calculate it and let us know. بس يا شباب أي سؤال على الكونسبت هنا. زي ما قلنا الباقي calculus يعني it's not a big deal for me. However, how did we get this? This is the most important part. And whether your answer makes sense or not, it has to make sense. The average value should be within the range of the random variable. It cannot be outside the range. طلع لك رقم خطأ أو يعني كبير أو صغير لازم تعرف إنه this is wrong.
دكتور
تفضل.
3 over 32 should be multiplied by the whole equation.
Yes.
Maybe
Yes.
this is the mistake they are having.
Maybe, I'm not sure.
Because you didn't use the parentheses.
Yeah, maybe. So I also make another mistake. Parentheses here. I forget to put them. 2 over 3 is for everything يا شباب. Thank you. So اللي طلع له 64 it might be multiplied by 3. I'm not sure. طيب يا شباب find it out. It's not a big deal يعني. طيب what we want to talk about also here in this class is the moments. لو تقفل ميكروفونك لو سمحت. The moments. The moments are defined according to or an extension of the expectation or the average value. So the average value can be thought of as the first order moment, M1, which is expected value of X. This is the mean. This is the first order, نسميها moment. طيب, what about the nth order moment? Nth order moment about the origin of a random variable X equals, we call it here M sub n, and it's nothing but the expected value of X to the power n. Expected value of X to the power n. Expected value of X to the power n means that we use the same averaging except that we put next to the PDF what? X to the power n. Okay? So it's integral from minus infinity to infinity X to the power n multiplied by the PDF. And for the discrete random variable, Mn or the nth order moment around the origin equal expected value of X, which is nothing but we make the summation and we multiply P of X by Xi to the power n. Okay? This is called the moment around the origin. We'll talk about several examples in a minute. What do these moments mean? خلينا ناخذ أول moment here, M0. What is M0? M0 is expected value of X to the power 0, right? What is this equal to? شباب.
1.
1, right? 1.
Yes.
Why? Because it's integral of fx of x, and we multiply whatever inside. What is x to the power 0?
1.
1, right? So what is the integral of 1 multiplied by fx of x dx?
Density
By
function is 1.
Yeah, it's the area under the curve, which is 1. The area. For any random variable to have a valid PDF, the PDF should integrate the area under the PDF equals to 1. So M0 is nothing but the area under the curve. What about M1? M1 هذه هي. It's the expected value of x, which is equal to the mean or the average. Okay? Now, expected value, or M2, sorry, which is expected value of x squared. Okay? هذه نسميها the mean value, the mean squared value. Value of x. يعني مثلا إذا الx كان عبارة عن voltage, then expected value of x squared will be the mean squared value of the voltage. Okay? Which is nothing but the integral of x squared fx of x. وهكذا. في بعض المومنتس لها معنى, في others that don't have a meaning. However, in general, for advanced analysis of random variables or statistics, ويسموها higher order moments. They do have some applications. Higher order moments have some applications. So these are what we call moments around the origin. Around the origin. Around 0. And there are other moments which we call them central moments. Central moments are moments, however, whatever inside here, we subtract, before raising to the exponent, we subtract the mean. So mu n, which is the nth central moment, is the expected value of x minus the mean all to the power n. In order to calculate this, simply we have the PDF, we multiplied by whatever inside the expectation, which is small x minus the mean to the power mu. So this is here the mean. And because of that, we call it central moment, because we are subtracting the central of the PDF, the center of the PDF, اللي هو المفروض يكون في معظم الأوقات المين. Okay? For the discrete case, mu n is the expected value of x to the power x minus the mean to the power n, which is nothing but the probability of xi multiplied by whatever inside, which is xi minus the mean to the power n. So every time we calculate this, we take xi, the value of xi, we subtract from it the mean, and then raise it to the power n. Let's see what is mu0. What is mu0? It's expected value of x minus the mean to the power 0, right? Which is the integral from minus infinity to infinity of 1, which is whatever inside here, because anything to the power 0 is 1, multiplied by the PDF, which gives us what? The area under the curve, 1, right? What about mu1? Mu1 is expected value of x minus x bar, which is the mean, to the power 1. So we just remove the parenthesis 1. So it's expected, and we will see in a minute, part of the expectation operator properties is it is linear. And because it's linear, we can separate any minuses or pluses. So expected value of x minus x bar equals expected value of the first one minus expected value of the second. Expected value of x bar equals x bar by definition. Expected value of x bar, which is a constant, it's x bar, and this gives us 0. So the first central moment equals 0. Okay? And this is basically what gives us the general rule, the central moments. So the central moments, always we do the same thing as moments. However, before raising to the power n, we subtract the mean. You can see here. What does this give us when we subtract the mean? It gives us some information about how variable the random variable around its mean. Some information give us some central moments give us a spread around the mean. Some others give us a skewness, as we'll talk in a minute. There's a very famous central moment which is mu2. ايش mu2 يا شباب؟ This is expected value of ايش رايكم؟
x minus x bar all square.
All square. Okay. And what is this equal to? هذا شيء درسناه قبل كذا في chapter 2 لكن ما تكلمنا عنه كيف نحسبه. This is equal to what we call the variance. The variance. تتذكر الفاريانس لما كنا نتكلم عن ال Gaussian random variable قلنا هذا هو ال Gaussian random variable. It's centered around AX, right? وقلنا في شيء اسمه variance. الفاريانس كان سيجما x سكوير. سيجما x سكوير قلنا لما يكون كبير ال PDF تصير كذا عريضة. لما يكون صغير ال PDF تكون نحيفة. Focused. So the variance here gives you how spread the random variable is around its mean. X bar. How spread? Is it widely spread عريض ولا focused نحيف narrow? So this is what we call the variance, and it has a very specific notation which is sigma square x. Sigma x square. This is a very specific notation. مثل ما قلنا ال x bar. X bar كانت الميو m1 was x bar, right? This is the mean. X bar is a very special notation, only for the mean. Similarly, for the second order central moment, we call it the variance. Why? Because it's very important, and we give it the name or the notation sigma x squared. Why is it important? Because it gives us a very important characteristic of the random variable, which is how is it spread around the mean. Is it widely spread؟ لما تاخذوا اختبار أهم شيء تسألوا عنه أنتوا إيش؟ الأفريج والستاندرد deviation, right? The standard deviation is the square root of this. Standard. From here, we get the standard deviation. Standard deviation. Standard deviation is the square root of the variance, which is sigma x. Standard deviation is not a moment, not a moment. However, it is related to the variance by being its square root. And it's very important parameter also. It gives us the same information about the same information that the variance gives us, which is how spread is the random variable around its mean. طيب, any question يا شباب? These central moments, what do they mean? the moments, how to calculate them. طيب, now let's talk about the expectation operator. Expectation operator.
Sorry, Doctor.
تفضل.
With the central moment n equal 1, what does we call it?
Mu equal, central moment is mu. You mean mu equal 1, mu 1?
Yes.
Nothing. It's equal to 0. ما لها معنى.
Okay.
يعني it doesn't have any meaning. Mu, the central moments, the first meaningful moment is mu2, which is a variance, sigma x squared. For the moments around the origin, the first moment that has a meaning is m1, which is the mean, the average. تمام. طيب الآن expectation operator, لو تتذكروا إيش expectation operator كان؟ E of whatever inside. Now, if this is equal to x, إيش يعطيك؟ E of x إيش يعطيك؟ شباب.
Expectation of x.
Expectation of x, which is the average. If we put x to the power n, what does this mean?
Central moment.
Not central. The moments around the origin. If we put x, so the x minus x bar to the power n, what does it give us?
Central moment.
Central moment. So this gives us central moment. These are moments around origin. Origin. أو باختصار moments. Origin. And this gives us the average or the mean. So basically, whatever you put inside gives you different meanings. So this E of whatever inside is what we call expectation operator. And this is a very important operator in statistics or in probability. So because of that, it's very important to understand how to manipulate it, how to use it. And because you will find it in many, many places. Later when we talk about two random variables, we'll talk about many, many applications of this expectation operator. When we talk about random processes later, also we'll use it. So it's very important to master it, to know how to use it. And to know how to use it, you need to understand the properties of it. So the first property is that expected value of a constant equals the same constant. Why? This is the proof here. Expected value of a constant C equals the integral, by definition ترى, equals the integral of whatever inside the expectation, we put it next to the PDF. وهذا اللي تعلمناه. Expected value of anything is the integral of the PDF multiplied by this anything. Now, when you integrate a constant multiplied by the PDF, you can take the constant outside because it's constant, has nothing to do with the integral. And then you are left with the integral of the PDF, which is equal to come?
1.
1. And hence you get C out of as the answer. So expected value of a constant is equal to the constant. And طبعا this makes sense. نحن لما نقول expected value of the constant, what do we mean? We mean the average of the constant, صح? This is average of C. Right? So what is the average of C? If C is a constant, what is its average? If I have a constant, what is the average of that constant? It's the same constant, right? ما في شيء اسمه average of a constant. It's a constant. So logically, expected value of a constant equals the same constant. Mathematically, here is the proof. Logically, expected value of C is the average of C. طب the average of 2 is كم? What is 2, right? ما في شيء اسمه average of 2. It's already 2. طيب ممتاز. So you need to understand what does it mean logically and mathematically how to prove it. Now the second property is the linearity. So expected value of a constant, multiplied by g of x, function of x, plus b, another constant, multiplied by h of x. So a and b are constants. G of x and h of x are two functions of random variable x. Now this is equal to a multiplied by e of g of x plus b multiplied by e of h of x. And this is called linearity property. Linearity property. So expectation is a linear operator. Okay? If I multiply and take a function, it's the same as instead of taking the expectation of the whole thing, it's the same as whatever the product, expectation of the function, plus the second constant multiplied by the expectation of the other function. And the proof of this is as follows. Expected value of agx plus bhx equals whatever inside, we just multiply it by fx of x and integrate, right? So when we do that, it's the same as we can separate the integral into two integrals, between them summation. Ag of x multiplied by the PDF of x, and the second integral, which is this one, and the second integral is bh of x multiplied by fx, which is this. And you can take always the constant outside the integral, so a outside, b outside, and you end up with a multiplied by, what is this? This is the expected value of g of x, right? And what is this? It's expected value of e of x, e of expected value of h of x. واضحة يا شباب؟
Clear. Yes.
Any question? Now these two properties, we use them here when we found the mu1, which is expected value, which is the first central moment. It was the expected value of x minus x bar. لو تلاحظوا, what we did is we already separated them because there's a minus sign between them. You can take the first part, which is expected value of x, minus the expected value of the second part. The first part is x bar. The second part is the expected value of x bar, which is also x bar, then expected value of a constant. We already use these properties here. طيب. Any question? طيب, now let's talk about some of these moments. تكلمنا على variance قبل كده. Variance, which has a very specific notation, sigma x squared, which is mu2. This is by definition the expected value of x minus x bar to the power 2. All to the power 2. Now, we know that the expectation is a linear operator, so we can just open up this. It's what? It's expected value of whatever inside. What is inside? We can open up this to the parentheses of square. This is equal to x squared minus 2x bar x plus x bar squared. هذا عبارة عن x bar to the power square, to the power 2. اللي هو الافريج تربيع. Now, so what we did is we just open up the square inside the expectation. Now applying the second property, we can just separate these into three different expectations. Expected value of x squared minus 2, now minus expected value of this, 2x bar x. So we take whatever constant outside, constant, 2x bar is a constant, expected value of x, plus the last part, which is expected value of x bar square. What is x bar square? Is a constant also, right? And hence its expected value is equal to itself here. واضح شيخ شباب؟
Yes.
طيب, so the first one is M2, which is the second moment, the first term. The second term is 2x bar, and what is this? Expected value of x,
The mean.
which is mean. So basically we have 2x bar square, right? But we have here x bar square. So 2x bar square plus x bar square gives you, يعني بس أفصلها زيادة. This is equal to expected value of x square minus 2x bar x bar, right? واضح يا شباب؟
كيف دكتور اكس بار طلع الثانية؟
من وين طلعت؟ إيه هذه هي. This is expected value of هذه second one. Expected value of x is x bar.
المين يعني اكس بار.
إيه المين هو. إحنا خلاص اتفقنا إنه when we talk about moments x bar means the mean. لما نتكلم على الجروبز أو sorry السيتس a bar is the complement. We need to agree on the notation يا شباب. X bar when you talk about moments equals the mean. So here 2x bar x bar plus x bar square. So 2x. So what do we have here? We have expected value of x bar x square minus 2x bar square plus x bar square. ايش يعطينا هذا؟ M2, which is the second moment, minus كم؟
M1 square.
M1 square, which is x bar square, the average square. لازم نميز, this is different than this. So expected value of x square and expected value of x square. ايش لهم علاقة برأيكم؟ they equal ولا not equal؟ شباب.
not necessarily.
Not equal
not
دكتور.
necessarily. So basically not necessarily equal. ممكن بالصدفة يكونوا equal لكن not necessarily equal. So these are two different things. This is the second moment and this is the mean squared. Okay? The first moment squared. So the standard deviation, sorry, the variance equals, as you can see, equals the second moment minus the mean squared. هذا هو هذا الفارينس. تمام يا شباب؟ Now the standard deviation, as we mentioned, is the square root of the variance, equals the square root of the variance. Okay? زي ما قلنا, both of them give you the information about how spread the random variable around its moment. This exercise is very important. What we did here is we opened up the parentheses, which is x minus x bar squared, and we simplified. So what did we do? We simplified until we got some known moments. And this is a very important exercise that you need to be aware of and to practice. Now, there's another central moment that is important. Not as important as the variance, but it's important also, which is mu3. Mu3 is expected value of x minus x bar all to the power 3. This is called the skew. It's a measurement of the skewness. What does skewness mean? It gives you information about whether the random, whether the PDF is skewed to the left, skewed يعني مايل مركز على اليسار ولا على اليمين, or central. When mu equals 0, mu3 equals 0, when you have a symmetric PDF. So it's not skewed, it's symmetric. It's not skewed to the right or to the left. If we have skewness to the left, we have positive. mu3 is larger than 0. When it is skewed to the right, mu3 is less than 0. When you have mu3 equals 0, it means it's symmetric PDF. Okay? Now, in general, if PDF is symmetric around the mean, the mu3 and all the odd central moments will be 0. Why is that, شباب؟ ايش رايكم؟ If I have a symmetric PDF, then all the odd central moments will be 0. Why? Because I'm multiplying x to the power 3 multiplied by fx of x dx, and I integrate from minus infinity to infinity. Now this is even around the mean, and because not x to the power 3, it's x minus x bar to the power 3 fx of x. Now if this is central around the mean x bar, then when I subtract x bar and raise to the power odd, the positive will always cancel the negative. The positive, which is around less than which is above the x bar, will cancel the parts below x bar, and hence you always get 0. Similarly, if you have to the power 5, to the power 7, and so on. Okay. Now we define the skewness coefficient, or coefficient of skewness, as mu3 divided by the standard deviation to the power 3. So this is x, sigma x to the power 3. Standard deviation to the power 3. Let's have an example. We have exponential distribution. The exponential distribution, it has this PDF. It's exponential. That starts at A and then decays. It decays with a speed which is equal to 1 over b. So what is the expected value of x? What is m1, sorry? It's the PDF, which is هذه عبارة عن PDF fx of x, and multiplied by x. Now you need to solve this by part. You get a plus b, and we have found this before. It's a plus b. This is the average value. m2, the second moment, is the expected value of x squared. So whatever inside here, we take it inside in the integral. And this is the PDF. So again, you need to integrate by part twice to find this as the mean square value. Now, if I want to find the variance, do I need to repeat these integrals? Well, I can use whatever I have found before.
We
Right?
can use what we have found. Yes.
Exactly. Because the variance equals the second moment minus the average square. So we have the second moment here minus the average square. This cancels this, and you end up with b squared. اوكي لو تتذكروا نحن قلنا انه if I have a small b this is a if I have a small b this starts at 1 over b, right? If I have a small b I have a PDF that looks like this. If I have a large b this will be 1 over b and this will be like this. So you can see that b squared here is the variance. B squared gives you how spread, how wide the distribution is around the mean. واضح شباب؟ شباب clear؟
Yes.
Yes, دكتور.
يس دكتور.
كلير.
أي سؤال؟ طب we'll stop here and next time inshallah we'll continue with an example and the rest of this example and other examples. أي سؤال يا شباب؟ Time is up, so